Hello, welcome to this behind the scenes video series which documents the design process of a Eurorack module. This is the module itself in question, the tràigh transistor ladder low pass filter, which I originally designed as the second module that I launched as Instruō back in 2016. So this is the original here, but I revisited recently for this project. So there's a project overview video which I'll link to below. That kind of explains a bit more the background to this project. The series itself is very much long form, so there's a lot of time lapse sections. This is warts and all, so this definitely includes a lot of mistakes that I made through the process, PCB iterations, occurring because of that. But yeah, I tried to capture this comprehensively to show more of an overview, like a realistic example of the design process for a module. Yeah, Instruō very much started out as a media project where it was less about the final designed result, and it was more I wanted to capture and depict the design process. So it was time-lapse capture of schematic, PCB tracing, assembly, testing of the original tràigh module. So it's a format of content I've been quite keen to revisit, and this tràigh module project gave me an opportunity, I think, to try this out again. So thank you for watching. Hope you enjoy. So there's the original graphic. Yeah, so my sister drew this as a wedding present for me and Emma, which is pretty cool. She draws these big complex Celtic knot patterns. So this is the first one I've seen done of a pet, but yeah, there are quite a few really cool designs that I've done a faceplate with one in the past. Previously, I was on a prototype sequencer. Yeah, so this is the process of I just took a photo, I then digitized it in Illustrator, just doing the image capture, so playing about with the settings to try and get the clearest resolution that I could of it. It translated really well. Yeah, this is just me test fitting, just sketching, trying out different positions to best put Winston. So like quite early on, I sort of realized that I wanted a bigger version of the image on it, covering the majority of the faceplate. So yeah, I got pretty close to what in terms of placement of what it ended up being, but this was trying out different ways of highlighting lines. Got it completely wrong here because I ended up changing it to outlines of something that's already a sort of line graphic drawing, like the Celtic knot. So yeah, this is just a trial and error process pretty much. I come up with an idea, I just go through the process, try it out, see if it works. So this is going with a sort of contrast pattern of the graphic against the main graphics of the faceplate. Ends up not working at all. I don't think it's way too busy. But yeah, I gotta try something out. Especially that bit there with the two legs on the left. Like that's a really dense bit, and I think that part of the graphic, the original, is so really beautifully contoured. Like just the way that it sort of knots in itself between the two front legs. I think it's really cool. So yeah, it doesn't do it justice there. So I quickly sort of realised that, I think. But I go through the full process of adding in overlays and text, as you can see. So this is trying to clear it out a bit more by clearing out the inside of the interface sort of outlines. Yeah, it's a bit much. There's just matching, manually matching some of the original widths, because the tràigh's an old graphic design. So I think the only Illustrator file I had was an older, more of an orange color, I think, in place of the gold. So it was a while until I settled on this value. Yeah, that's me realizing that I got the graphic completely wrong. So this is now trying the exact same thing again, but with the not outlined version of the graphic. Yeah, but the original version of the tràigh panel, it was the wrong colors, and I think a lot of it was already expanded to objects. So I didn't have fonts to work with for the text, so a lot of it was just moving stuff around or having to recreate the vector shapes of like the outlines around the fader, stuff like that, because a lot of them were already expanded to filled in rectangles. Here we are. This is me digitizing Justine's signature to go in the bottom right. I think our original plan was to use, so the stamp logo that I use, which is my signature at the top of the module, that's from an actual little stone carved stamp that I got as a gift. I think it was my grandmother like made got a bunch of them commissioned for me and my sister and my cousins, sort of like using the family name. But I'm not sure Justine knows what hers is. So the graphic that she went with for her logo, that's a hand drawn signature. Here we are. So this is where things get a little bit weird. I'm trying different placements of the larger Winston graphic. There are bits that I like. I like where his head is sitting in the middle. I think that spacing works quite nicely, but there's a limit to how much I could keep it isolated. Like it ends up just being a disembodied head, which it kind of ends up being shortly anyway. But I think the bigger issue, it kind of looks like the fine tune the attenuator over the FM input, that sort of loop and circle. I think it makes him look like a cyborg. Like it looks like he's just he's got a wheel for a front leg, which it's kind of cool, but not really what I was sort of going for. So yeah, that I worked on it a bit further. I tried like just cutting out extra bits so that to try and find that if there was a good balance of disembodied head versus spacing of the controls. Yeah, greyhounds are very strange shapes, so trying to fit the shape of a greyhound into anything kind of takes a bit. I think I'm going to try it, putting it to the grey that I use for a background. It's hard because it's not even how it would look in actual panel form. It's a mock-up of that.
Yeah.
So here I've made the change to the grey stop mask color, which I think definitely contrasts a lot better. So yeah, this process was just finding that right balance of level of overlay of the gold of the outlines of the parameters over the shape. And just removing everything around the outline and inside of the patterns. And matching the text. Okay, I now have this faceplate where I want it. Took a bit of fine tuning, so I had to create a border around any of the gold. So I wanted to make clearance because the plan is anything that's grey currently is going to be stop mask, but it's also going to be gaps in the copper. So this will be white FR4 that we'll use as the substrate, but I'm not going to backlight it. I'm just going to have it exposed, and the reverse side of the faceplate is going to be a full copper plane. There we go. I don't have it set up, but that's just showing FR4 at the moment. So this will be fully a fill plane on the back. So it will be copper fill, and the top's going to have the pattern with stop mask and copper avoid as well. So it means that anything that is plain here, I guess that's a question. I need to decide whether I want to do that over the full face of it. I think so. I think I'll do it so that anything that's just grey is going to be sort of textured and recessed slightly from the rest. What I've done here, the Winston graphic down here, I've got this shape outlining it, so it means I can hide everything but that. I'll need to add another layer here. Let's do that. This will be copper stop avoid. A copper avoid. Copy that. This here. Hide that. Delete that. There. So that's a shape that I can export and use this to create a shape that will remove copper. So it means that it will be solder mask. So there will be a textured step down. Background, here we go. And text. Oh, I'm showing the wrong layer. What's going on here? Where's this? That one. There we go. Reference and drill holes. That's it. Too many layers in this file. Cool. Yeah. So it means that the majority of the faceplate is going to be copper fill, with these being solder mask exposed. So that will be kind of a step down from black solder mask down to gold. But here will be that outline shape will then step down to being recessed slightly, and then this will be a sort of gold on top in the traditional way that I've done panels. That's the plan, at least. I might do something similar with this. Yeah, I think I will actually do that. So let's copy this, put this here, hide these. I'm going to combine this to being a single shape. Flip that. I'll copy this color value. Make it outlined. And make it the same as this, which is 2 point. Bring in the copper again. Yeah, so this will be the same sort of effect, where it'll be slightly recessed. I think that will be cool. I might step it up slightly, make it 2.5. It's too much. 2.2? Try 2.2. Yeah, I think that will be good. Okay, so this is the process of going from, or this is my process. This is something I've figured out. Of how I translate this over to KiCad. There might be better ways of doing it, but this is something that I've muddled through and found some solutions to. Yeah, it's a bit tricky. There's quite a lot of things going on at the same time. So what I'm going to do is I'll focus on this shape first, which is there. Oh, interesting. That's one. Okay, so I want to show that completely. This I might temporarily change to white. Let's do a duplicate layer. Duplicate. Stop. White. There it's high contrast. This will make sense momentarily, hopefully. Okay, so this will be my first shape, and I'm going to export as PNG file. I'm going to put this in my tràigh graphics folder, but I'm going to create a new folder in that called to KiCad. And this is where I'm going to put in my collection of PNGs as I create them. So this will be stop white. There's quite a lot of back and forth here, some bit of trial and error. Stop white, PNG, use artboard, export. So artboard's there, so it's using the actual outer dimension, so it's actually brought in a bit from what's visible, because this has got an edge that extends either side of the actual artboard size. And I've been doing this with 1000 ppi, which is possibly overkill, but it's given me some good results. So there we go. I should now have that as high resolution PNG file. Yeah, that holds pretty good resolution, looks like. Now I'm going to go to KiCad and open up the image converter. Load source image. Try again, try graphics to KiCad, stop white. So this is loaded in. I'm going to hit negative to invert it, and this is where I want to find the threshold that this is going to give the most articulation, and as I bring this up it's going to thicken it up slightly. So I want to kind of find a good middle ground to make sure that all the detail is best captured. Yeah, this is a bit of trial and error. I'm finding where the sweet spot is. So it seems to breach threshold at 1. Then again at 88, 89. Yeah, 89. So I'm kind of looking at regions here that are quite, that's where there's a gap, so that's where I want to make sure that the detailing is as optimal as possible. Let's just go bang in the middle. Let's go 50. For some reason this pads by 0.3 millimeters, it seems. I'll keep the ratio locked and go to exactly 128.5. I guess that's rounded up to 1 decimal place for the HP, but that should be fine. I'm going to do this on solar mask, because I actually do want it on solar mask. And footprint and export to clipboard. So I'm just going to paste this in, Command V. There we go, that's my shape. So I now want to modify this to make it more fit for purpose. Get rid of that silk screen and hit E, edit footprint. Here we go. And I want to double this up with a copper avoid. So this is exposing, this is a stop mask, so it's going to, anything that's purple will be a gap in the solder mask. I don't want the copper stop to be exactly in line, because that's got the risk of exposed copper and then unintended gold edging around it. So I want the copper stop to overhang slightly. So to do that, I'm going to select all. So I might need to do this manually. I think there's a weird thing with selecting all where, yeah, this only gives me a create array option. I'm not sure why this is. So I want to, I think it's something to do with stuff at the origin. Let me try just moving them. Get those out of the way. I select all this. Right click. No, still there. I think it's something to do with the origin. So let's go like that, that. Grab all the stragglers. There we go. Okay, if I right click now, ta-da, I've got these options. So I'm going to create a rule area from selection. Don't delete object on conversion, create a bounding hull. So this is going to be how much it's overspilling the exact shape dimensions. I'm going to select front copper, keep out zones, and remove these. We don't want to keep out pads or vias or tracks. And let's go with point. Let's start with 0.2. I think that might be absolute overkill. This might be way too much. Okay. Yeah, I think that is too much. think I maybe want an order of magnitude. I think I want 0, 2. Rules. No, it's not rules, is it? Yeah, rule error. Okay, so that was 0. Let's try this. Don't delete. Okay. I think that might work. It's maybe cutting it a bit fine. It's also hard to gauge size when it's vector. You can keep just zooming in and it just gets bigger. Let's go one step more. Let's go, that was 0, it was 0.02. Let's try 0.05. Yeah, I think that's a bit better. Let's try with that. Save, close, and it should update it. Anyway, it's already updated. So I want to center it on this. So I'll do this. E, this will be 5.08, which is 1 HP, times 8, because I want it to be in the middle. So I want it to be half 16. I'll do that plus 100, and then 128.5 divided by 2, so halfway on the vertical. Boom. Perfect. There we go. So we can see the stop mask. There's no copper for it to restrict yet, so let's do that. Let's just put in a full copper fill. This will be ground. I want both. I want solid. B to fill. There we go. I actually want it to create islands though. Check that. E, remove islands, never. Minimum width. Let's leave it at that just now. See how it looks. Okay, so I actually do want it to fill in all these little gaps here. So, to do that, clearance, minimum width. Let's just set it to the absolute minimum width, which is 0.25. That's good. Yeah, so that's filled in all there, but it's also not pushed the edge out as far. So I might want to play with that anyway. So that will be not that. Oh, I think this might be a custom rules. Constraints. Copper to edge clearance, let's go 0.3. There we go. So that's right to the, that's in line with these shapes. So let's go to render. So here we can see these are exposed copper areas. Oops. So that will be a textured step down from here to solder mask only to stop. I feel like I might be able to get away with a smaller clearance than the outline. It's hard to know. I guess I could check what I did on the 5U Oct. That kind of looks about the same, I would say. Yeah, okay, let's go with that. I think that's akin to what I did on the expander. Cool. Okay, that's good. Okay, phase one. Let's move on to our copper, which is also, where are we? This one. Okay, let's remove them. So most of these are going to be everything but the signature and Winston are going to be stop mask only. Oh, I lost the text. There we go. So let's do this by hiding that. Export this as an image. I think I'll modify it on the KiCad side, and then I'll do a separate pass that's just these. Yeah, let's do that. So here's a trick. I do actually need to do this not as a copy and paste, but saving it as a library. File, export as CU, use artboard, PNG, 1000. Okay, let's do another image convert. Okay, so let's flip that, and I want to go somewhere in the middle again. Let's keep it at 50. If we need more or less, we know we're starting from middle ground. Let's see how this looks. Yeah, I think that will translate well. Okay, so we need to bring this to accurate as well. And I'm going to do the solder mask footprint, and I'm going to export to file. And this is going to be, it's just a new folder. Okay, that's there. Add, I think I need to do this from footprint editor, then add this library, which is here. Oh, I need to make this a .pretty folder project. Okay, where are we? Faceplate lib, there we go. Pin, put that at the top, and here we go. That's there. So here's the trick. I want to make this copper as opposed to stop mask, which is what I exported as, because in the image trace, there's a finite range of options. We've got silk, fab, solder mask, blah, blah, blah. So we actually want this on a copper layer, but to do that, we need to modify the actual content of this file. So I'll bring that to a text editor. Sure. Okay, let's put that there. And what I'll do is I'm going to duplicate this, call one stop top, because this is actually going to remain as stop, and this one I'm going to convert to copper. So here I want to find F mask. So F mask is the layer, which is what all this polygon data is on. So let's copy that. Let's do find and replace. Find all these and replace that with, double check this, f.cu. Front, copper. Replace all, save, quit. There we go, that's it, modified. It's now all copper. The way I want to do this now, so everything but these areas I want to be copper. So here, this version, I'm going to delete everything except the signature and Winston pattern. Save that. Yeah, that's come out really clear. Yeah, the image convert tool is really impressive. Does it very well. Okay, save that. Where's the top file? Oh, do I need to import that? Discard. Okay, let's try adding stuff. Ah, they're both there. Cool. Okay, let's add the stop one first. Actually, let me check. Yeah, I did make that the right size. Okay, let's delete that and set this to being 5.08 times half the face weight, so 16, so times that by 8, add 100, and then 128.5 divided by 2. Beautiful. So this should all be exposed copper now when I view it. Nice. What I could do here, let's check what this color is in hex. Over here, go to our board, stack up, mask, solder mask. Let's change this to being that. Let's bring the opacity down a bit. Just a bit. Let's go there. Okay, new hex number. Save that. Set that. Go to our board, stack up. Nope. Finish. Copper finish. Inig. Okay, so that should emulate gold. It'll basically turn everything silver yellow. Save 3D and use board stack up colors. That is way too light. That's meant to be that dark grey color. I think when the opacity way too opaque. Let's go fiscal stack up, custom. I guess I go darker. Let's try that. See how that looks. Better. Let's change the FR4 to being a lighter color. Actually, no, that's good enough. That's going to be subtle. That's probably not too dissimilar to what the color will be. Because imagine that's looking through the FR4. I'll try making the FR4 a bit opaque. Let's make it slightly yellowish. Somewhere there. And a bit opaque. Yeah, it's a bit more white. Let's go there. There we go. Cool. Okay, now let's try creating a gap around that shape and that shape. So here I want to hide all that, and this is just black on white, or dark grey on white. File, export, PNG, use artboard, 1000, let's go white background. There we go. Okay, let's open another image converter. Okay, this is what I want. Kind of doesn't matter what level, what layer. Let's go silkscreen. Export to clipboard. That. Delete that. And E. Edit footprint. So these I'm going to create shape from selection, rules and area, top copper, keep it zone, keep it. Use center lines and delete the source object after conversion. Let's do that. There we go. So this should remove copper in those exact shapes surrounding that, but these have, that's got copper fill. I think I need another. Oh, that's what I need. I also need to add this one because that's the actual copper shape. So let's try this first. So let's put this one in place. So let's try just, yeah, they'll overlay okay. Align horizontal. Okay, that's aligned. That's the wrong size. I think I forgot to, I forgot to do that. Okay, try that again. And delete that one. I'm going to go back here and change that to 0.5. And 50, why not? Export to clipboard, paste, edit, highlight, paste selection, create rules, centerline, delete, top, keep it fill zones. Okay, save, quit. Okay, let's check these now. Vertical. That still doesn't look quite right. It looks too much on the top. Those are not aligned. What's going on? I think I might need to manually align these. Okay, Y coordinate, X coordinate. There we go, that's good, that is in line. I think the auto alignment on vertical and horizontal was not actually aligning the origins. Yeah, weird quirk. Okay, so let's just do one at a time. E, and this will be 5.08 times 8 plus 128.5 divided by 2. Same for this, 5.08. Actually, let's do it for the other one first. Put this on last. I want to see with this in the render. There we go. Okay, so now viewing this, that should be all solder mask covered apart from the shape itself, which will be the FR4 color. Yes. And we just want that to be like double layered as gold. And if we do this, 5.08 times 8 plus 128.5 divided by 2. Save, render. That's it. Like that. The G's slightly too low. I mean, that should be the same as the original, but yeah, that should be good. Cool. I think this all looks good. Yep. Everything's aligned. I think that's us done. I think I might just add a few little bits of detail on the back and then come up with what I'm going to decorate the back of the PCB with. But yeah, that's a module. That's pretty exciting. Okay, so first prototype is built and finding some minor issues. The filter circuit itself works perfectly, sounded very nice. Calibrations worked. The LED drivers are all working. What I have found is there is a slight chance of minimum brightness of the faders when they're lit, and that'll be down to just DC offset bias, fundamentally at certain op amps. So if it's not at 0 or below, then there will be a minimal amplitude driving the op amp that's driving the LEDs, which white LEDs are very prone to lighting, so it means that they can have a minimal off level. Might be able to work around that. I need to have a think. I need to check it's here. It's possible I could throw in like a very high impedance like pull down, but that's also because it's a non-inverting buffer. It would offset here, which again might not be an issue. I could try like a 10 meg pull down to -12. It's needlessly adding a DC offset, so I think I'm happy enough leaving it there. Where I mean, you can see when the fader's all the way down, it's off. So I think I can live with that. Functionally, it's fine. It's driving, showing the amplitudes, which is nice. Realised an error with the flip-flop divider, or two errors actually, one more obvious than the other. The one that I should have picked up on is if I patch in here, this should go to channel 1, but that should also drive the flip-flop that normals here, which that signal should then be flip-flopped again to drive here to give me sub 1, sub 2. What I did, which I guess I was just on autopilot a bit, so this is the frequency divider, so this is what I've used in previous sub-square oscillator circuits. The output of Q of the first flip-flop is driving the second flip-flop, which means we're getting a sub from this sub. But that's not actually what I want. I want to be able to patch in here and have that go to the second flip-flop to drive the normal here, so that you could patch in a signal here, patch a different signal here, and get the sub of this signal. At the moment, if you patch in here, you break the normal from the flip-flop, which also breaks the. Is that right? No, I think you still get a sub from this, so it's not ideal. It's not what I was intending. So yeah, bit of a silly error on my part. The other issue is I was, I guess, overestimating the simplicity of a single supply powered CMOS flip-flop. So this signal here is pulled down to ground, so it's essentially voltage divided, 100k to 1 meg, branched from the input signal. But, and that's before the attenuator, but what I have realised is this gives you a full bipolar audio rate signal, which the negative portion seems to be not playing nice with this direct clock input. So I did a simple test where I just put in a diode in series, just circuit bending that in to halfway rectify. That worked. That improved the stability of the first frequency divider, but only really if it was a rising edge signal. So if it was a sawtooth versus a ramp or a square wave signal, it was fine. But if I put a ramp in where it's going to be ramping up from 0, so it's basically going from minus 10 to positive 10, or minus 5 to positive 5, like that, so ramping up, then it wouldn't be a hard rising edge to clock it. It would be a negative fall. So for some reason, if I patched in a signal here, sawtooth wave, I got nothing from this flip-flop output, but there was enough of a transient swing, I guess, when it goes from full positive to full negative, that was maybe double triggering this fast enough to influence the, oh, hey Winston, to influence the second flip-flop. So I was getting a first sub from the second flip-flop, third channel, which is interesting. That's the strange quirks of analog circuitry. So what I'm going to do is make this an active buffer. I can do that with just a basic transistor. So I'll have it an active low buffer stage. I do have a transistor left over here, but that's in a pretty awkward place. That would be quite a long run just to make use of that missing channel. So I'm just going to add one more dual NPN, the same part. That should be fine. And add that as a transistor buffer to that clock input, and then to this clock input from this channel. The AC coupling seems to work fine. When they are working as drivers, it's working as sub-squares, which is great. So this is what I'm intending. So this is pulled up from 5 volts, which will be from the same regulator. That should be absolutely fine, the ZXTR. Okay, so that will be a pulled high signal. I've got this 1 meg here to simulate any load, although I don't know if that's actually needed for the simulator. So 5 volts, that's showing here. As soon as this goes high, that's high signal at the base. It causes the transistor to conduct from collector to emitter, so this then shorts to ground. So we then get a falling edge, and then when this goes back low, this becomes a rising edge. So this should be, I'll change this to a sawtooth, and that should be bipolar sawtooth. Yep, here we go. So that's a depiction of what we're going to get. So I've got quite a slow falling edge there. If I maybe go with a 10k, 100 gig. What do I have? I have 1 meg? Yeah, there's a not so slew there, but it'll work. It's going to give me a hard rising edge, which is the main factor that I need to drive the flip-flop. So that's the plan. I'll put that in here and then another one in here, disabling that connection there. And there should be plenty of space. Yeah, I might move this circuitry over a little bit to the middle. Yeah, play about. But everything else is looking good. The faceplate should actually arrive in the next few days, I think. So I'll need to do one more hardware revision of this. Previous prototype works other than the flip-flop stage, but the filter sounds good. And when you get, if you put a square wave in, then the subs work, and yeah, sounds really full. I also need to add in some annotations. This needs to be a C50K, so an anti-log tapered pot for resonance to get the right feel. Yeah. So we're back to time lapse. This is me implementing the transistor buffer inputs on the flip flops. Yeah, it seems hindsight's 2020, but it feels like a gross oversight that I made the mistake of mislinking the two stages of the flip flop and not thinking that it would need additional buffers. It makes sense based on circuits I've built in the past, but I think based on the circuit simulator, which is what I kind of rolled with initially, yeah, a CMOS input, it should theoretically be sound with any voltage. It's just looking for that threshold, but it being single supplied versus bipolar, that was the main issue. So that's me just moving more tracing around and just getting it all neatened up, pushing to get. Last couple of tweaks, that's adding some pull down resistors. There we go. Okay, we're on to actual assembly. So this is the pre-prep work where I'm changing out some resistor values because yeah, the input stages were a little bit. I think the voltage divider on the input was just not quite pulling it down enough. Pre-pop. So this was split over a weekend. I think I might have got the footage in the wrong order in this sequence, but yeah, David and Sebastian were both in at various points helping me out with populating all the boards. But yeah, I think I pretty much got the assembly done in a weekend. Once the boards were populated, it was just blitzing through the soldering, which you can see a spool just quickly ran out. Adding the headers. For some reason I put the power headers in last after all the top stuff was assembled. I think because this isn't a repeat project, it was I only needed done once for this production batch. But, there we are. Faceplates and brass nuts. Yeah, you can see them building up in that rack in the background. Yeah, it was a pretty streamlined build. I think it's an old module, so I've built it for years, arguably. But yeah, this new version, it was I got the actual assembly quite optimized. And here's the test packaging. So that's some extra stickers I had of my signature stamp. So that's on the top. Actually, these are the craft boxes that the Glasgow Synth Guild use for the Octones. So I ended up using the rest of the stock that they had for this batch and then replenishing that stock for them. And there it is, the final piece with a brass die included with each try.